Hello, thank you for tuning in to this video. In this second part of time, speed and distance, we are going to learn about one of the most important concepts of this topic, which is relative speed, and its application in train-based questions. Now, to understand relative speed, I am going to use a very interesting story with two very interesting characters, Romeo and Juliet. So let's say Romeo and Juliet are distanced at 100 kilometers, with Romeo having speed of 15 kilometers per hour and Juliet having speed of 10 kilometers per hour. Now, using this data, let's look at the first question. If Romeo and Juliet they leave at the same time, when will they meet? So I'm going to consider their directions of travel as shown by the arrows. Now we know time taken is distance upon speed. Consider the term relative speed after 2 minutes when I tell you to. Right now you can take it as distance upon speed. Now in this case we know that both of them are going to meet somewhere, which means they are traveling for the same time. So time is constant. Now as we have learnt in our previous video, if time is constant, speed will be directly proportional to distance covered. Now here we know that speeds of Romeo and Juliet are in the ratio 3:2. So distance covered will also be in the ratio 3:2. So now if 100 kilometers is covered in the ratio 3:2, Romeo is going to cover 60 kilometers and Juliet is going to cover 40 kilometers. So to calculate time from Romeo's side, we can use the ratio 60 upon 15 or 40 upon 10 from Juliet's side is going to give you 4 hours. Now till now I have not made any use of relative speed. We are going to introduce this concept now and understand how this question can be solved so much quicker using relative speed. Now first we need to understand two very important things about this concept. First, relative speed comes into existence only when we have two or more objects moving simultaneously. Second, relative speed is never the actual speed. It is the effective speed which is applied to cover a particular distance. You'll understand this better with few examples here. So here in this case, because Romeo and Juliet are both together trying to cover this distance of 100 kilometers, the effective speed applied is Romeo's speed plus Juliet's speed, which will give you the relative speed as 15 upon 10, that is 25. So it's just one line solution, 100 upon 25, 4 hours. So in short, relative speed will be the addition of the speeds when objects are moving towards each other, and relative speed will be the difference of the speeds if objects are moving one after the other or in the same direction, just because in that case the effective speed to cover the distance is going to be more. They are going to take more time, right? So let's see that type of an example. If Romeo follows Juliet, so in this case their direction of motion is going to be like this. So here Romeo will definitely take more time to reach Juliet and effective speed will be lesser. So it will be 15 minus 10 to cover a distance of 100. So time taken is going to be 20 hours. Third example, if Romeo leaves on time and Juliet leaves 2 hours late, when will they meet? So consider their direction of motion as shown by the arrows over here. Now because Juliet is leaving 2 hours late, Romeo in the first 2 hours would have already covered 30 kilometers as you see. So for the remaining 70 kilometers, that now both of them will start moving together. So now relative speed is going to come into picture. So remaining 70 kilometers will be covered by 70 upon 25 plus those 2 hours that Romeo traveled alone would be the total time taken for them to meet. Similarly, in this case, instead of Juliet, sorry, if Romeo leaves 2 hours late. So if Romeo leaves 2 hours late, Juliet in the first 2 hours would have covered 20 kilometers. So now for remaining 80 kilometers, relative speed would be 15 plus 10, that is 25, plus 2 hours that Juliet has traveled alone will give you the total time taken. Next example, if both of them leave on time, but after an hour Romeo realized that he forgot his wallet. So he goes back and returns. Now when will they meet? Now this is interesting but pretty simple. So concentrate on the diagram. In the first hour, both of them are going to travel. But after 1 hour, Romeo realizes that he forgot his wallet, so he goes back home. But Juliet has still traveled in her own direction. So now at the end of 2 hours, the situation is Juliet has traveled 20 kilometers and Romeo is still at his place. Now both of them are again going to start traveling towards each other. So it is nothing but same as the previous case, 80 upon 25 for this remaining distance plus 2 hours you can consider for Juliet who has traveled alone to cover those 20. Alright, now for the next question, I'm going to introduce the third character in this love story, which is Juliet's dad. So now he is distanced at 50 kilometers from Juliet and he has a speed of 25 kilometers per hour. Now the question is, if Juliet's dad starts following both of them after they met on the ideal time and place, that is by none of them getting late by either any of the reasons, when and where will he catch hold of them? Now, in this case, of course, the direction of Juliet's dad is going to be this. Now, because both of them have met at ideal place, that is at 60 kilometers from Romeo and 40 kilometers from Juliet. So, when the couple starts running and the dad starts following, so that distance which they have to cover is 90 kilometers. Because they are moving in the same direction, the relative speed is going to be the difference, which is 25 minus the speed of the couple. Now, what will be the speed of the couple? It will always be the minimum of Romeo and Juliet. Why? Because Juliet can't travel at a speed more than 10, and Romeo is not going to leave her alone. So, your answer is going to be 90 upon 25 minus 10, which gives you 6 hours. So, if you calculate in 6 hours at a speed of 10, couple is going to cover 60 kilometers. In 6 hours at a speed of 25, Juliet's dad is going to cover 150 kilometers. So, they are going to meet at Romeo's place. So I hope this story is going to help you understand this concept better. Now let's look at few more applications. A policeman reaches a burglary location 2 hours late. If a thief is escaping at 40 and police is chasing at 50, how long will it take? So very simple, because thief has already moved for 2 hours, thief would have covered 80 kilometers. Now, because police is following him, the relative speed will be 50 minus 40. That gives you 8 hours. Next, distance between two places is 570 kilometers. A train starts from A at 50 kilometers per hour at 6 a.m. Another train from B at 80 kilometers per hour at 7 a.m. towards each other. At what time will they meet? Now be careful. One train starts at 6, another train starts at 7. So first you need to make the first train move 1 hour. So first train will cover 50 kilometers in the first hour. So now at 7 a.m. the distance left is 520 kilometers. Because they are moving towards each other, the relative speed is going to be 50 plus 80, which is 130. So it will be 4 hours from 7 a.m., which means they are going to meet at 11 a.m. Next, Two trains, they start at the same time from Pune and Delhi, and they proceed towards each other at 80 and 95 respectively. When they meet, it is found that one train has traveled 180 kilometers more than the other. Find the distance. Now, we can see from their speeds that second train will always travel 15 kilometers more than the first train every hour. Now we know that in total second train has traveled 180 kilometers more. So 180 upon 15, which means both the trains have traveled individually for 12 hours. So now if I have to calculate the total distance, it will be 80 into 12 for first train, 95 into 12 for second train. Total will be 2100 kilometers. Now let's look at the questions relating to trains. Now to solve these questions, I'm just going to give you some standard data over here. For train 1, length and speed, train 2, length and speed, be careful of the units, and the length of the platform. Now let's see the first question. How long will it take for train 1 to cross the person standing in the middle of the platform? Now for this, I would like you to concentrate on my video and look at the visuals over here. So let's say that there is a person standing right in the middle of this platform. Okay. My question is, how long will train 1, so let's consider this pen as train 1, train 1 take to cross this person completely? Now, please look here carefully. The time taken by train 1 to cross the person will start right when the train is starting to cross the person till this. So this is the time that we have to calculate. Now we know time taken is distance upon speed. Distance will be nothing but the length of train 1. Speed is again going to be length or speed of train 1. So 100 upon 120 into 5 by 18. If you remember to convert into meter per second as we did in the first lecture, that is going to give you 3 seconds. So 3 seconds for train 1 to pass this person. Now, even if the person would have been standing in the beginning of the platform, end of the platform, or the center of the platform, time taken for train 1 to cross this person will not change. Alright, next question. How long will it take for train 1 to cross the platform completely? Now this is the platform. Okay, let's assume, and this is train 1. So from wherever the train 1 is coming, time taken will be starting to calculate from when the train 1 starts crossing the platform, that is this, till the train 1 has already crossed the platform. So total distance to be travelled will be length of platform plus length of train 1, which gives you 600, and speed will be speed of train 1. So that gives you your answer as 18 seconds. Next, how long will it take for train 1 to cross train 2, which is waiting at the platform? So let's say there is a train 2 which is waiting at the platform. Now my question is, how long will train 1 take to cross train 2? So similar as one in the previous question, total distance will be length of train 1 plus length of train 2, and speed will be speed of train 1 because that is the one in motion. That gives you 7.5 seconds. Alright, how long will it take for train 1 to cross the person sitting at the window of the center compartment of train 2 at the platform? Now this is interesting. So let's say this is a platform with train 2 and there is a person sitting at the window of the center compartment of train 2. Now the question is, how long is train 1 going to take to cross this person? Now this is nothing but very similar to the first case that we saw. Doesn't matter where the person is. The two objects in the question is train 1 and the person. So doesn't matter if it's the train 2 that the person is in. But time taken will be again time taken by this train to cross this person, right? So it will be again 100 upon speed of train 1, which will give you 3 seconds. How long will it take for train 1 to cross train 2 running in opposite direction? So now we have more than one object moving. So here's where relative speed will be introduced. So if train 1 and train 2, they are moving in opposite direction, time taken to cross each other will start from this moment and will end at this moment. So total distance is length of both the trains, and speeds will be the addition of both because they are moving in the opposite direction. So that will give you 45 by 11 seconds. Next, how long will it take for train 2 to cross train 1 running in the same direction? Now, train 1 is running and train 2 is supposed to cross train 1. So I know what most of you are going to tell me. Total distance will be length of both the trains, and speed, because they are moving in the same direction, it will be 120 minus 100. Correct? Now please be very careful. Train 1 is running and train 2 has to cross train 1. So if you observe speeds, train 2 is slower than train 1, which means this is never going to be possible. If the case would have been that train 1 had to follow train 2, then yes, total distance would be length of both the trains and speed would be 20 kilometers per hour. But when train 2 has to follow, because it is slower, it is never possible that it is going to cross. Alright, so after seeing all of these things, we can conclude that for any questions related to trains, time taken can be calculated as length of train plus width of object divided by speed of train plus or minus speed of object. Now, in the first few cases, we saw that width of object. So, for example, if there is a person, if there is a pole, width of the other object is negligible, which is why that term will be 0. But if we have another train, platform, or a bridge to be crossed, then that distance will also be added. Similarly, for the denominator, if we just have train in motion, the second part, which is speed of object, will be 0. But if we have more than one object moving, like two trains or train and a bus, then we'll have speed of other object also. So this is the summed up formula. I can use this formula to solve any questions for trains. Alright, let's see one good application over here. A train running at 54 kilometers per hour takes 1 minute to cross the platform and 10 seconds to cross the person standing on the platform. Find the length of the train and length of the platform. So here you see a mix of units given to you. So first let's take the first case. Where train is crossing the platform. Now because we have minute and seconds, I am going to first convert the speed of train from kilometers per hour into meter per second. So that's 15 meter per second. Now it takes 10 seconds to cross the person, which is why 10 is going to be length of train upon speed of train, which is 15. So length of train will be calculated as 150 meters. Now if I take the case of crossing the platform, which it takes 1 minute to, converting 1 minute into seconds, 60 seconds is equal to length of train plus length of platform divided by speed of train, which is 15. So length of train plus length of platform is 900 meters. We already know length of train. So I can conclude that length of platform will be 750 meters. This is one very good application of all that we have learned. Let's look at this one more question. A train crosses a man traveling in another train in opposite direction in 10 seconds. But the train requires 30 seconds to cross the same man if the train were traveling in the same direction. If the length of first train is 180 and that of second train in which the man is sitting is 120, find the speed of the first train. So I just have two very simple cases over here. In first case, both the trains are in the opposite direction. So for that, my formula will be 10 is equal to 180 upon S1 plus S2, right? So that is going to give me my S1 plus S2 as 18 meters per second. Now for the second case, it's going to be 30, and because it's about first train crossing the man, distance will always be just the length of the first train. So again 180 upon, because they are in the same direction, speeds will be S1 minus S2. Thus S1 minus S2 is 6 meters per second. So now if I solve both of these simultaneously, I will get my speed 1 or speed of train 1 as 12 meters per second. So guys, this was all about today, relative speed and trains. In case you want to reach out with any of your queries and doubts, this is where you can reach out to me on. If you liked this video, if you found the content helpful, please do not forget to share it ahead and subscribe to this channel to keep getting these updates. Thank you.